Black holes. Just the name sparks curiosity. They are regions in space where gravity is so strong that nothing, not even light, can escape. Imagine a giant cosmic vacuum cleaner, relentlessly sucking in everything that dares to venture too close. Black holes are not empty spaces. They are incredibly dense objects with masses many times greater than our sun. Imagine squeezing all the mass of the sun into a tiny ball just a few miles across. The boundary of a black hole is called the event horizon. Once something crosses this point of no return, it can never come back out. It's like falling into a waterfall. There's no swimming back upstream. These mysterious objects are not just science fiction, they are real and play a crucial role in the evolution of galaxies, including our own Milky Way. To understand black holes, we first need to understand stars, these giant balls of hot gas that illuminate the universe. Stars form in giant clouds of gas and dust called nebulae. Gravity pulls these materials together. As more and more matter clumps together, the core heats up under immense pressure. Eventually, the temperature and pressure become so high that nuclear fusion begins. This is like a giant hydrogen bomb continuously exploding. This fusion process releases enormous amounts of energy, making the star shine brightly. Stars spend most of their lives in this state, happily fusing hydrogen into helium and other elements. Our own sun is currently in this stage. However, stars don't live forever. Eventually, they run out of fuel and can no longer support themselves against the relentless inward pull of gravity. This is when things get interesting, and the drama of black hole formation unfolds. The fate of a star depends on its mass. Smaller stars like our sun will eventually puff up into red giants and then gently shed their outer layers, leaving behind a dense core called a white dwarf. But for massive stars, the story is dramatically different. When a star significantly larger than our sun exhausts its fuel, the core collapses in on itself. This collapse happens in a fraction of a second. The core implodes with such force that it creates a shockwave that rips the outer layers of the star apart in a spectacular explosion called a supernova. Supernovae are some of the brightest events in the universe. If the core that collapses is massive enough, gravity will win the final battle. The core will continue to collapse indefinitely, squeezing into an infinitely small point called a singularity. This is the heart of a black hole. Black holes come in different sizes. Stellar mass black holes, as the name suggests, form from the collapse of massive stars. These are the most common type of black holes. Then there are the behemoths, the supermassive black holes. These monsters lurk at the centers of galaxies, including our own Milky Way. They can have masses millions or even billions of times greater than our sun. Imagine the appetite of a cosmic giant that big. While we can't see black holes directly, we can detect their presence by observing their effects on nearby stars and gas. These objects are crucial to understanding the evolution of galaxies and the very fabric of space-time. Black holes, once considered merely theoretical curiosities, are now essential pieces of the cosmic puzzle. They challenge our understanding of gravity, space, and time. As we continue to explore the universe, these enigmatic objects will undoubtedly continue to fascinate and inspire us.